Okay, so we're going to look at Lisp, and I've already given you a tour of Lisp, and you've started on your implementation, so you understand Lisp to some degree there. And if we were to just look at, programming in Lisp, that introduction I gave was probably enough for you to go to the Common Lisp manual and go and understand how Lisp works. Okay. So what's going to be different in what I'm going to talk about is that I'm going to actually talk about implementation. Okay. And I've kind of already hinted how we do that. We just copy the environment. So I want you guys to get some practice with copying. So we'll make this also an extra credit part in the next assignment. So there is something called Lisp interpreter settings that you guys haven't dealt with so far. It's a static class, and it's got many options. It's got many getters and setters, and one pair of getters and setters has to do with whether the environment should be deep copied or not. Okay. So if the setting is, by default, we say the environment should be deep copied, so we are in Lisp semantics, and if we set it to true, then we want it deep copied. And what happens is that you guys actually don't do that deep copying. You just define the copying. So you guys use something called the interface called function, and its implementation called basic function. And you've used the constructor and the two getters in it: get lambda, get environment, and the constructor that takes lambda environment. So this particular constructor actually does the following. It says that, look, if the settings say deep copy, then I'm going to call copy on the environment. Otherwise, I'm going to, and that's the environment I will store. That's the environment that will be returned by getters. And if the it is not deep copy, then I'll just do the environment. So there were some questions last time saying, what should I do in copy? And I said, yeah, go ahead and return this, because our settings did not say deep copy. Okay. So we now have to deal with that function. Okay. And if we could be a little efficient and copy only if there are free variables in lambda, but that's not what Andrew's code does. And this is just to make this more clear, that what you guys do is you say function factory.new instance lambda environment. You don't kind of know or you don't care what's happening there, and that actually goes and calls basic function lambda environment, and that does the copying or not. Okay. So this is how things work, and we want to now have ML-like semantics also. So we want to basically define a copy function in environment that doesn't return this, that actually returns a copy. Okay. So way back, we talked about shallow versus deep copy. So does anybody want to define what a shallow copy might mean in this context and what deep copy might mean? So if I'm copying the environment, yeah.
This is a shallow copy when you just kind of like pass the same location, but deep copies when you make it in that regular location.
Okay, so this is important. There's actually three things here. There is just assignment. Assignment is that you just give the pointer. So if I say A is assigned B, A gets the pointer that is stored in B. Now I'm not saying A is assigned B. I'm saying A is assigned B dot copy, and that copy can be shallow or deep. And so we're talking about something else now. So there's two kinds of copies you can imagine. So try to imagine what it might mean in this case and in general. Sorry? Would receive. So in both cases, if I say A is equal to B, A is assigned B, then A has a pointer assigned to it, but it happens to be the same pointer stored in B. Okay. If I say A is assigned B dot shallow copy, again A is assigned a pointer. Sorry?
But in shallow, you're assigning a value, and deeper, you're assigning a pointer.
We just, A still got the pointer. Okay, A's got the pointer. Now the question is pointer to what? So in this case, if I go and say A is assigned B, then and I've got this abstract environment on the here, B will have the same, B will point to abstract environment. So okay, forget about shallow versus deep. What do we want copy to be in that right now? What do we want here? What kind of structure do we want from the copied? Sorry? The frozen environment? So we want a copy of this particular object, right? Can we have this? I made a copy of the parent object that was meant to be copied, but it's got pointers, components, and they point to the same. So now the copy and the original object share pointers, share objects. Is this what we wanted? Let's talk about that. Sorry?
Shallow copy, you don't want to be able to change after you copy it. So if I copy it and then I change what the original environment was, my copy will still be what it was when I copied it.
That's what we want ideally, right?
Yeah.
In our case. And are we getting this here? If I change this particular environment, if I change this scope here, if I change this scope here, does this environment get the change? Yeah. So even though I've copied the object to be copied, okay, so abstract environment, I've got a new object there. So I do have a copy. But the copied object and the original object share pointers. Okay? So it is a copy, but it's a shallow copy. It's not a deep copy. Deep copy means that you copy. So we'll define that. So ancestor environments are not frozen, and a deep copy would do something like this, where there are no shared pointers. Okay. And lots of people get copying wrong. They tend to, when they they have to implement deep copy, they end up implementing shallow copy. Okay, the shallow and deep copy idea was actually invented, as far as I know, in the context of Smalltalk, and that term has continued. Okay. So deep versus shallow copy definition. So we say B is a copy of A. Anybody want to define a generic? So in both cases I did copying. One I called shallow copying, the other I called deep copying. So what's something that unites both of them? You want to try to give a definition? So if you that's a good one. That if you go in, A and B are interchangeable right after the assignment. So shared output means that, whatever methods, any methods you call on one, a method sequence you call on one will result in the same result, have the same result as a method sequence in the other. Okay. Maybe I want to give a different definition in terms of graph structures. In general, each of these objects can point to a graph. What can you say about the two graphs? I'm not sure if you guys have heard this term in your algorithms class. Yeah?
Copy every node and edges.
So that I want to give a definition for that unites both shallow and deep copy. What? Consistent? Have you guys heard this term in algorithms? Isomorphic? So isomorphic means there's a one-to-one correspondence. I'm not going to try to define that technically, but you guys, algorithms class, you didn't do graph isomorphism? Okay. So isomorphic is, basically there's a one-to-one correspondence between the nodes and edges in two graphs. Okay, and that's essentially saying the same thing, that we want the behavior to be the same. And so now you want to distinguish between deep copy and shallow copy. Which I've kind of said. Yeah, good. In shallow copy, changes in A can affect B's behavior. Okay, whereas, okay, so we can just say that they don't, in deep copy, they do not share pointers. Okay, and in terms of graph, and shallow copy is, if it's not a deep copy, it's a shallow copy. Okay, it is a copy, but otherwise it's shallow copy. Okay. Questions? Okay, so you have to implement deep copy, and I told you deep copy can be tricky. And part of the deep copy is actually given to you. So we have to copy the environment. Okay, so Andrew, you had a question?
I was asking, so like, deep copy has
Yeah. So copy means isomorphic, and now the question is whether you share pointers or not. So you have two graphs, and each A and B points to a graph. Okay, and if you start from A or you start from B, you get a isomorphic graph. You get the same structure graph.
saying that though, you said that we were wrong, we weren't confused, because we said that a deep copy takes the pointers so that it'll keep changing along with the source. You said that was wrong. It sounds like what you're saying now. I'm a little bit confused here.
Okay, so I'm confused about what you're trying to say.
The deep copy, when it copies the pointers so that if the source changes, the copy changes. But the shallow
No.
doesn't
Deep copy. If the source changes, the destination doesn't change. That's what the picture showed. It's a deep copy. You don't share pointers. In shallow copy, you share pointers.
So if I change the source after making a shallow copy, it does change my copy?
That's a shallow. It's not a full copy. You copied part of it and not deep. You didn't go deep enough. Going deep enough is going down to the tree. You are going down there. Okay. So you just got that reversed. Okay. So and we'll go and see some more examples here. So we have an environment, and we need to go and copy the scope also. That means, okay, and scope is an object that's given to you. So let's go and see how scope works, and that may give us a hint on how do we have to implement our deep copy, and also it brings out some subtle issues. So a scope has a pointer to a variable map, as we know, okay, and the map has a bunch of slots, and these slots point to keys and values, okay, and it's got not only a variable map but a function map. So we're doing a deep copy, okay, we say copies that returns a scope. So we create a new scope, okay. We don't point to the original variable map, we point to our own variable map, and we have our own slots, and these slots have copies of the keys in the original. Okay, that's what a deep copy would be. Okay, so if I make change to the first one, if I make changes to any part of the structure of the original, it doesn't affect any part of the structure of the new one. That's what a deep copy is. Okay. Now, can you think of a more efficient copying than this? Because we've copied everything, so that's kind of inefficient. A more efficient copying that gives us what we want, freezing the scope. So I want to do a kind of shallow copy here. I don't want to do the full deep copy and yet not lose anything in terms of freezing the environment. And this is not for any structure. Yeah.
Only copy the Lisp environment? The static environment?
No, because anything, every part could change, right?
Right. Yeah.
So that would be one way to go. Okay, and function map too. So, I mean, this brings up the point that we don't want changes in one to affect changes in the other, right? Assuming they can be changed. Some objects can't be changed. And in our scope, the keys and values are what? When you do a set queue, you're doing what? So it's either identifier or a string as a key, and the value is a okay. Keys are strings, values are S expressions, both immutable. Okay. So we can just do this. And as it turns out, you don't have to worry about this because Andrew's implemented this, but I just wanted to tell you that, we don't have to have, this is again a benefit of immutable structures, yeah.
I was just going to say, you could also do copy underneath.
Yeah, okay, but that's done in operating systems often, and that's yet another dimension. Okay. What Robert said was, and that's more like lazy evaluation, that do copy on write. Only if something changes, then do a copy, and keep track that you should have done a copy. Otherwise, don't do a copy. So maybe that should be another extra credit added on. Okay. But that's really an example of form of lazy evaluation. Okay. We don't copy if we don't need to. Okay, so scope copies implement Lisp into a skeleton. So is this a deep or shallow copy? Well, by our definition, it's a shallow copy, but we'll just call it a deep logical copy, and we'll say it's a shallow copy in which the only shared pointers are pointers to immutable structures, and the other pointers are not shared. Okay, so this is effectively, and this is sort of bringing in the point that immutable structures make our life more efficient in many ways, and here's an example of how. Okay. So one of the extra credits in your assignment is going to have involved implementing this copy for the environment. Okay, the scope is already implemented for you, and it's tricky. It's a recursive function, so just make sure you don't get it wrong.